Alright, so the first thing we want to do always is see if there is a GCF greater than 1. Anything, or honestly, any term that is other than 1. So if you put this into the calculator in slide 1, and you put GCF of 1, 6, and negative 16, you're going to get a 1. Now, you don't need to divide a 1 because it's not going to change the trinomial. So since it's not going to change the trinomial, we just write the original one. Now, if it's any other number than 1, you have to change the trinomial. You have to divide it out. So if it's a negative 1, a negative 5, positive 6, whatever it may be, you have to divide it out. That's the whole point. So since this was just a GCF of 1, the original expression is fine. So then we have to do our A times C. Our A is 1, our C is negative 16. So A times C gets me negative 16. My B value is going to be 6. Now please use the factor sheet that's on Schoology. It gives you all the different options. Now we need a negative 16, so our smaller number will have to be negative because our B value is positive. So then negative 2 and 8, negative 4 and 4, so on and so forth. These two numbers are your magic numbers. Negative 2 and 8. Because negative 2 times 8 gets you negative 16, but add to get a positive 6. Now the whole point of those numbers is to write them here, negative 2 and 8. Those are your x's. Now go back to the first term if you need to. First term, first box. Last term, last box. And then you take the GCF of the rows, and you take the GCF of the columns. GCF of x squared and x, 8x is just x. GCF of negative 2x and negative 16 is a negative 2. GCF of x, negative 2x is x. GCF of 8 and negative 16 is a positive 8. Now notice that this is positive because my first term was positive. Notice this is negative, so I had to take out a negative because my first term was negative. Now inside here, you put the outside of the area model. So your factors are x minus 2 and x plus 8. Now go back to your original problem. We did not take out a GCF other than 1. So this is it. That is all you have to do. Now on problem number 2, it's slightly different because we have a negative first term and we are not allowed to have a negative first term. So no matter what, I have to divide out of negative. Now what number do I have to divide out? It's whatever number slide 1 tells me. So negative 1, 9, negative 20. The calculator tells me the GCF is 1. But I know better. I know it has to be a negative 1 because my first term is negative. Now it's your responsibility to actually divide that negative 1 out. So negative x squared divided by negative 1 gives you x squared. 9x divided by negative 1 gives you negative 9x. And then negative 20 divided by negative 1 gives me a positive 20. The whole reason why we did that, we can't have a negative leading term. So we had to actually factor it out. So your new simplified expression is the GCF times the trinomial. Since it's a new expression, you're going to have a new a value, which is always next to x squared. You're going to have a new b value, which is always next to x, and you're going to have a new c value, which is always the constant. So a times c is 20, and then negative 9. So the two numbers that work are negative 5 and negative 4. I'm asking you politely to check the factor chart, okay? Mess around with the negative numbers, figure out which one will get you a positive one. Now the reason for the negative 5 and negative 4, that is splitting up your x's in the area model. So write negative 4, write negative 5 in the diagonals. Don't forget to write the x's. And then go back to your slide 4. You guys can go back. Your new a value is 1x squared. Your new c value is 20. And now you find the GCFs. GCF of 1x squared and negative 5x is just a 1x or an x. Negative 4x and 20, your calculator is going to tell you 4, but the first term, our leading term, is negative, so we have to divide out a negative. GCF of x squared and negative 4x is x. GCF of negative 5x and 20 is going to be negative 5. Now, if you put this into the calculator, it's going to say it's wrong. The reason why it's wrong is because you forgot to put this negative 1 goes on the outside because that's the greatest common factor of the beginning. So you have to make sure that you put that as the answer as well. And then problem number 3. You're going to find the GCF of 6, 10, and 4, which in this case is a positive 2. It's positive because the 6 is positive. So then you actually divide it. 6x squared divided by 2 is 3x squared plus 5x and then minus 2. So all I'm doing is dividing all three of these terms. Now you have a new a value, a new b value, a new c value. So then you can fill out the diamond with those numbers. So then we're going to get negative 6 and we're going to get 5. The two numbers that work are 6 and negative 1, because you multiply, get negative 6, and add to get 5. So, what we do next, that 6 and negative 1 matter. That 6 and negative 1 goes in the diagonal, and then put the x's. Then your first term, which is 3x squared, and then your last term, because remember, we've divided. We've divided by the 2. I know it went away, but I'm typing it now. My first term is 3x squared, and my last term is negative 2. So I'm going to put that in the box. And then you're going to find the GCF. GCF of 3x squared and negative 1x is just x. GCF of 6x and minus 2 is going to be a positive 2. GCF of the column is going to be 3x. And then be careful, first term is negative, so I'm going to take out a negative 1. So once again, if you just put the two binomials as an answer, you're going to get it wrong. You have to remember, in the first step, you divided out a 2, So you're going to have to put a 2. It just doesn't magically go away. You have to put it as part of the answer. Now for slide number 8, I just want you to put this expression in an equation. I want to see what you notice about these two graphs. This is called a parabola. I want to see what you wonder and what you notice. And then we will talk about it later tomorrow or even on Monday. And then for slide 9, it's just vocab. Slide 10 and 11, you're just going to put this in the right spot. So on and so forth.